three views of a function. Mathematicians should be able to represent relations and functions in three forms: rules, tables, and a graph. So we want to make a table and graph the following functions. So here is our rule. So that's one way we can represent it. So another way is to represent it with a graph or a table. So let's pick some values for x. Let's say we have -2, -1, 0, 1, and 2. So to find my outputs, my y's, -3 times a -2 is a +6, plus 1 is 7. -3 times a -1 is a +3, plus 1, 4. -3 times 0 is 0, plus 1, 1. -3 times 1 is a -3, plus 1, -2. -3 times 2 is a -6, plus 1, -5. So that's the second way we can represent our relation. So now let's graph it. -2, +7. -1, +4. 0, 1. 1, -2. And 2, -5. So let's look at continuous and discrete data. So continuous data includes measurements like temperature, length, weight, and they're used with a solid line to indicate that it's continuous. Discrete involves a count of items, so like the number of people, the number of cars, how many you're counting. So let's take a look at example 2. Suppose your group wants to produce and sell CDs. It costs $250 to produce a master and $3 per CD to produce. We want to create and graph a function to show this relationship. So the rule would be, well, we know we're charging $3 for every CD we produce, but we're also being charged $250 to make that master copy. So if we take a look, let's pick some values. So let's say we don't produce any CDs, and we produce 2, 4, 6, and 8, for example. So we produce 0, 3 times 0 is 0, so we'd still have to pay $250 for the master. If we produced 2, 3 times 2 is 6, so we'd have to pay $256. If we produce 4, 3 times 4 is 12, so 12 plus 250 is 262. If we produce 6, 3 times 6 is 18, plus 250. 3 times 8 is 24, plus 250 is 274.